We are discussing application of derivatives. Now our next topic of application of derivative is increasing and decreasing functions. Increasing and decreasing functions. Application of derivatives are very simple. You should learn according to the graph. If you know the graph of a function, you can find the function whether that function is increasing or whether that is decreasing. For example, let's learn this concept with a normal graph. Let us see, we have a graph of this, and we have to find this function whether it is increasing or whether decreasing. So this function is y equal to fx. This function is y equal to fx. So first we have to find the tangent of this curve where it is parallel to the x-axis. The tangent to the curve where it is parallel to the x-axis. So we need to observe that in this graph, this is the point where the tangent is parallel to the x-axis, and this is also the point where the tangent is parallel to the x-axis. So these are the 2 points where the tangents are parallel to the x-axis. And let us consider the coordinate of this point on the x-axis as a0 and the coordinate of this point on the x-axis as b0. So these are the intervals for this. These are the intervals. Let us see, in this interval before a, this graph is what? Increasing. So we can say that fx is increasing in the interval minus infinite to a. Minus infinite to a, this graph is increasing. After that, this graph is decreasing in the interval a to be open interval. You must write the open interval in increasing and decreasing function. We cannot write the closed interval. Why? Because at this particular point, the slope tangent is 0. Neither increasing nor decreasing at that point only. So we need to write the open interval a to b. We can say that this function is decreasing. You see the graph? From left to right, from minus infinite to a, this function is increasing. From a to b, this function is decreasing, and again from b to infinite, this function is increasing. So we can say that fx is, in this graph, fx is increasing in the interval minus infinite to a union b to infinite, and fx is decreasing. Fx is decreasing in the interval a to b, open interval always. So this is a graphical concept to find the interval where the function is increasing or decreasing. You can draw the graph of a function and find the point where the tangents of the curve, the slope of the tangent is 0. So in these 2 points, we can say that the slope of the tangent is 0. We can say that f plus x is equal to 0 in this point, at this point, and f plus x is equal to 0 at this point also. But in all these points, minus infinite to a, the f plus x is always positive where the curve increasing. So we can say that here f plus x is greater than 0. When f plus x is greater than 0, means the curve is increasing. the curve is decreasing whenever f dash x is less than 0, and at this point f dash x 0, at this point f dash x 0, again increasing, again we can say that f dash is greater than 0. So this is a very important concept to find the interval. The concept is, if f dash x is greater than 0 in the interval a to b, then fx is increasing function in the interval a to b. This is a concept, very important concept for increasing. And for decreasing, f dash x is less than 0 in a to b, then fx is decreasing function in the interval a to b, and then f dash x is neither increasing nor decreasing, that is a monotonic function in some interval. F dash x means from interval minus infinite to plus infinite in this question. For some interval it is increasing, and in the next it is decreasing and again increasing. So minus infinite to plus infinite, we can say that this function is monotonic function. So what type of functions are strictly increasing, exactly increasing or exactly decreasing? You can observe the graph for that. Let us see. If we have to draw the graph of sin x, this is a monotonic function. Because the graph of sin x is increasing, then decreasing, increasing, then decreasing. So increasing and decreasing both in some interval. But if we have to find the graph of sin x in the interval 0 to pi by 2, the graph of sin x in the interval 0 to pi by 2, this is always increasing, strictly increasing. The graph of sin x, the sin x is strictly increasing in the interval 0 to pi by 2. But the graph of sin x is monotonic everywhere, in all real numbers. And what do we mean by the graph of log x? The graph of exponential function. How can we draw the graph of exponential function? Let's observe the graph of exponential function e to the power x. So the graph of e to the power x is like this one. This is the graph of e to the power x. You can say that fx is equal to e to the power x. So this type of function is always increasing. Because if you find f dash x in this is also e to the power x. An exponential function cannot be negative. We can say that e to the power x is always greater than 0 for all x is equal to, x is a real number. So we can say that fx is what? Increasing. Fx is strictly increasing. In all real numbers. Right? If you draw the graph of fx equal to x square, that depends on interval, it may be increasing, it may be decreasing. How can you draw the graph for x square? The graph of x square, y equal to x square. This is the graph. Y equal to x square. So from minus infinite to 0, this graph is decreasing, and from 0 to infinite, this graph is increasing. Yes, if you find the derivative of this, it becomes 2x. When x is negative, the graph is decreasing. When x is positive, the graph is increasing. No problem. So this is very important concept to find the interval in which the function decreasing or increasing. If f dash x, then the derivative is greater than 0, at that interval the function is increasing. f dash x negative at that interval, the graph is decreasing. Right? So these are the very important and the basic concepts of increasing and decreasing function. Then what type of important question can be asked in this topic? Let us see. The question is, find the intervals in which fx equal to x square minus x plus 2 is increasing or decreasing. Find the interval in which this function is increasing or decreasing. We can prove by the graph, but if you have to prove without graph, you can apply this concept. So first we have to find f dash x equal to what? 2x minus 1. If you find the derivative of this function, it becomes 2x minus 1. X square का derivative 2x and the derivative of x is 1. Now, first point, let f dash x greater than 0. F dash x greater than 0, then fx is increasing. So if f dash x greater than 0, then 2x minus 1 greater than 0. This is the value of f dash x. So x is greater than 1 by 2. Yeah, x is greater than 1 by 2. So therefore, we can say that fx is increasing in the interval 1 by 2 to infinite. X is greater than 1 by 2, means 1 by 2 to infinite. And second point, let us consider f dash x is less than 0. So we can say that 2x minus 1 is less than 0. So we can say that x is less than 1 by 2. Therefore, fx is decreasing. In the interval 1 by 2, less than 1 by 2, means minus infinite to 1 by 2. Minus infinite to 1 by 2. So these are the intervals. These are the intervals in which the functions are increasing and decreasing respectively. You can also draw the graph for this function x square minus x plus 2. You can find the intervals for increasing as well as decreasing. Increasing and decreasing. No problem, very simple. So by this we can find the interval for each and every function, like algebraic function, trigonometric function, exponential function, logarithmic function. No problem. You can find the graph or you can find the derivative of that function, and if f dash x is greater than 0, so find the interval for that. Whenever f dash is greater than 0, the function is increasing. If f dash x is less than 0, the function is decreasing. So let us see some more question. The question is, find the intervals in which the function is increasing or decreasing. Find the intervals in which the function are increasing or decreasing. And the question is very important question. Fx equal to x plus 1 whole cube and multiply x minus 3 whole cube. For increasing and decreasing, the very important thing, the function must be continuous as well as differentiable. Then only we can check its interval for increasing or decreasing. So these functions are continuous as well as differentiable, but because these are not signum functions. This is a polynomial function. This is a polynomial function. You know, every polynomial function is continuous as well as differentiable at all real numbers. And the function is continuous as well as differentiable. Then only we can check the intervals for increasing or decreasing. If graphs break at some point, we cannot check the increasing or decreasing. So, in this question, we have to find the interval in which the function is increasing or decreasing. first we have to find derivative of this, and after find the derivative we need to factorize that. So we can apply the product rule in this x plus 1 whole cube multiply the derivative of the second function, that is 3 multiply x minus 3 whole square multiply 1 plus x minus 3 whole cube multiply 3 multiply x plus 1 whole square. Now f plus x can also be written as x plus, we can take x plus 1 whole square common and x minus 3 whole square common. Remaining part we will get 3 multiply x plus 1 plus 3 multiply x minus 3. So it can be written as x plus 1 whole square and multiply x minus 3 whole square and multiply 3x plus 3x 6x and plus 3 and minus 9 plus 3 minus 9, that is minus 6. You can write it as 6 multiply x plus 1 whole square multiply x minus 3 whole square multiply x minus 1. This is f dash x. We have to check, we have to find the interval in which the function increasing or decreasing. Very simple. X plus 1 whole square is always increasing, always greater than 0. X minus 3 whole square always greater than 0. We need to check this one. So to find the interval, first we have to find whenever f dash x is equal to 0. So when f dash x is equal to 0, the x can be written as 1. So we can check by the number line, minus infinite to plus infinite, x minus 1 equal to 0, then x equal to 1 in this. Right? So now you can check the value, you can put the value less than 1 in this. Right? And when x plus 1 equal to 0, then x equal to what? Minus 1. When x minus 3 equal to 0, x equal to 3. In these 3 points, f dash x equal to 0. So we cannot consider the exact minus 1, exact 1 or exact 3. So now see, put the value, put any one value less than minus 1 in this and check the negativity or positivity. So if we put minus 1 less than minus 1, minus 2. So minus 2 plus 1, positive and positive. These are always positive. And if you put minus 2 minus 1, it becomes minus 3, negative value. Minus 1 to 1, we can put 0. If you put 0 in this, 0 minus 1, negative, again negative. If you put 1, the value is between 1 and 3. We can put 2 here. 2 minus 1, 1, positive value. 3 and more than 3, positive value. Right? So this function is increasing in the interval 1 to infinite except 3, and this function is decreasing in the interval minus infinite to 1 except minus 1. We cannot take exact minus 1 because at this point the function is what? The derivative is 0. So therefore you can say that fx is increasing in the interval 1 to 3 union 3 to infinite, right? And fx is decreasing in the interval minus infinite to minus 1 union minus 1 to 1. Leave the exact point minus 1, 1 and 3. So these both are the interval for increasing function because f dash x are positive in this. And these both are the intervals for decreasing function because f dash x are negative in this interval. By this we can find the interval for increasing or decreasing function in each and every question, no problem. We can use either logarithmic function, trigonometric function, no problem. Let us see one more question. We have to find the domain also for increasing or decreasing before finding the function increasing or decreasing. Let us see, the question is fx equal to log 1 plus x minus 2x by 2 plus x. We have to find the interval in which this function is increasing or decreasing. So before finding f plus x, first we have to find domain of this function. Then all possible values of x equal to domain. So what is the domain in this function? We have to check the function are increasing or decreasing in its domain only. So we can say that 1 plus x is always greater than 0. The function of log cannot be negative, cannot be 0. This must be greater than 0. It must be positive. So therefore x it must be greater than minus 1. This is the domain of this function. And also you can say that denominator cannot be 0. So x cannot be minus 2. X cannot be minus 2. We cannot take minus 2 in x. Right? So x is greater than minus 1 and x is not equal to minus 2. By combining these two, we can say that x is greater than minus 1. So we need to find increasing or decreasing in the interval minus 1 to infinite only. Because the graph of this function exists only in the interval minus 1 to infinite, not less than minus 1. So we cannot find the increasing or decreasing in less than minus 1. So now we can differentiate this function. F plus x can be written as 1 by 1 plus x minus, we need to apply quotient rule in this. We will get denominator multiply the derivative of numerator minus numerator multiply the derivative of denominator by denominator square. So now f plus x can also be written as 1 by 1 plus x minus, it becomes 4 plus 2x minus, we can be written as 4 by 2 plus x whole square. We need to simplify and factorize this, then only we can find the interval for which it is increasing or decreasing. So we need to find factorization of this. We can take LCM 1 plus x, 2 plus x whole square. Numerator can be written as 4 plus 4x plus x square minus 4. So f plus x can also be written as, you can take x common, it is 4 plus x divided by 1 plus x multiply 2 plus x whole square. So this is f plus x. Now we need to find the interval for increasing and decreasing in its domain, and domain is what? Minus 1 to infinite. Now if we equate it with 0, we can say that x equal to 0, x equal to minus 4, x equal to minus 1, x equal to minus 2. We can draw the number line and write the answer. If we take, let f plus x equal to 0, then x can be written as 0 as well as minus 4. Right? So we need to draw the number line from minus 1 to infinite only. No need to draw the number line before minus 1. Because the domain is what? X is greater than minus 1 except minus 2. Minus 1 to infinite. And what is the possible value? 0. There is only one possible value in between this, that is 0. So we need to check in the interval minus 1 to 0 and 0 to infinite. So in f dash x, we can put a value in between minus 1 to 0. That value is, I think, minus 0.5. We can put in minus 0.5. Minus 0.5, that is negative. 4 minus 0.5, positive. It can be written as negative multiply positive divided by minus 0.5. 1 minus 0.5, positive. And it is always positive. So finally it can be written as negative. So it is negative value. If we take any value between minus 1 to 0 in this, we can say that f plus x is negative. And from 0 to infinite, we can take any positive value. Any positive value. 0 to infinite, 1. We can take 1 here. 1, 4 plus 1, 5. 1 plus 1, 2. Each value is positive. So this is positive value. So f plus x, this function is negative in minus 1 to 0 and positive in 0 to infinite. So therefore we can say that fx is increasing in the interval 0 to infinite and fx is decreasing in the interval -1 to 0. This is the answer. By this way, we can find the interval in which the function is increasing or decreasing. Let us see one more question of trigonometric function. The very important question. This is y equal to 4 sin theta divided by 2 plus cos theta minus theta. First, we have to find domain of this function. Then we can find the increasing or decreasing interval. In the interval 0 to pi 2, this is already given. We have to find the interval in between 0 to pi 2 only. So, before finding the derivative of this function, first we have to find the domain of this function. What is the domain of this function? 2 plus cos theta is not equal to 0. 2 plus cos theta is not equal to 0. Why? Because cos theta is not equal to -2. So domain is only 0 to pi 2. So now we can differentiate this function. We will get y dash equal to, we have to apply quotient rule in this. 2 plus cos theta multiply derivative of numerator 4 cos theta minus 4 sin theta multiply minus sin theta divided by 2 plus cos theta whole square minus 1. So y dash can be written as, this is 8 cos theta plus 4 cos square theta plus 4 sin square theta divided by 2 plus cos theta whole square minus 1. Simplify this. We need to write the answer in the factors form. 8 cos theta plus 4. If we take 4 common, remaining part cos square theta plus sin square theta, that is 1 minus 2 plus cos theta whole square divided by 2 plus cos theta whole square. Now we need to simplify this. Therefore, y dash can also be written as 8 cos theta plus 4 minus 4 minus cos square theta and minus 4 cos theta divided by 2 plus cos theta whole square. So y dash can also be written as, we can cancel 4 with 4, we get 4 cos theta minus cos square theta divided by 2 plus cos theta whole square. Denominator is always positive because this is square function. So y dash can also be written as, you can take cos theta common, remaining part 4 minus cos theta and divided by 2 plus cos theta whole square. Now we observe that 4 minus cos theta cannot be 0 because cos theta lies between -1 to 1 and 2 plus cos theta cannot be 0 because cos theta lies between -1 to 1. So only cos theta is equal to 0 in this. Cos theta is equal to 0, then theta is equal to what? Pi by 2. So this is the only interval 0 to pi 2. So we have only one interval here, 0 to pi by 2. This is only the interval. We can check to put any value in between 0 to pi 2 in the place of theta. So if you put pi by 4 in this, this is always positive. This is always positive. If you put pi by 4, that means the cos pi by 4 is equal to 1 by root 2. So 1 by root 2 is positive and 4 minus 1 by root 2 is positive. This value is always positive. So we can say that this function is strictly increasing function in the interval 0 to pi 2. This is strictly increasing function. So therefore, y is strictly increasing in the interval 0 to pi by 2. 0 to pi 2. Open interval pi 2, not a closed interval pi 2. Because in closed interval pi 2 you can write cos pi 2 is 0. So y dash is equal to 0. At that point the slope of the tangent is 0. So therefore, the tangent is parallel to the x-axis. So we have to write the open interval in this. Closed interval 0 to open interval 5/2, right? So these are the very important questions for increasing and decreasing function. You can solve more and more questions in increasing and decreasing function. Like the question is, prove that a logarithmic function is strictly increasing 0 to infinite. Yeah, we know that. If you draw the graph for log, this is always positive, always increasing in 0 to infinite, right? So you have to solve more and more questions related to increasing and decreasing function. Now in next class we will discuss the next topic, that is maxima and minima. Thank you.